Here we have the myofibril. On the bottom we have the sarcomere, which extends from Z-disc to Z-disc, and it is the unit that contracts/shortens. Above that we have the I-band, where there's thin filament but no thick filaments, and it extends from the end of the A-band to the other end of the A-band. The A-band is where there's an entire group of just thick filaments. The M-line connects the middle part of each thick filament, and centered over the M-line is the H-band, where there's an area of thick filament but no thin filament.
Acetylcholine from motor neuron binds to acetylcholine receptors on the muscle, which depolarizes the membrane. Acetylcholine neurotransmitters are responsible for muscle movement and coordination.
Depolarization shoots down the T-tubule, which leads outside from the muscle fiber, which is the outer layer, into the sarcoplasmic reticulum, which is the inner layer.
Sarcoplasmic reticulum is depolarized, causing the release of calcium.
Released calcium binds to active sites by attaching to troponin, changing its shape and opening the active site. Troponin is attached to tropomyosin, both of which are located between actin filaments.
Myosin head connects to newly exposed active sites.
The myosin head on the myosin filament uses the energy it stored to pull actin filament, shortening the muscle.
ATP binds to the myosin head, which causes the release of myosin from the active site.
ATP gets broken down and releases its stored energy, resetting the myosin head.
If active sites are open and calcium or ATP are still available, steps 5 through 8 will repeat.
Eventually, the neuron signal will end, and when that occurs, the acetylcholine will get reabsorbed by the motor neuron, stopping the depolarization of the muscle cell. Sarcoplasmic reticulum will then reabsorb the calcium. Without calcium, active sites cover up, stopping the cross-bridge cycle and the shortening and extension of the muscle.
In these next two photos, we can see how the sarcomere can both extend and contract, showing both the extensibility and the contractility of the sarcomere, based on the actin-myosin cross-bridge cycle.